Welcome to Sahrdaya Tech Talks. Today in this video we are going to discuss about the embedded system design process. So in this video the contents that are included are the objective of the embedded system design process, its major goals, tasks, types of design approaches, and the level of abstraction. In the level of abstraction we overview on the different levels of abstraction, but mainly in this video we summarize only the requirement level. So first, the embedded system design process. The embedded system design process aimed at two objectives. First one, in the introduction of the various steps. Second one is the design methodologies. A design methodology is important for three reasons. First one, the optimizing performance of the performing functional test. Second one, develop computer aided design tool. Third one is easier for design team members to communicate. So optimizing performance means uh, to ensure that the everything is going on the correct order. The second one, develop computer aided design tool, in which the uh, developing a program in a conceptual manner. Uh, Second one is easier for design team members to communicate, in which if the embedded system process design is divided into several steps, which can make the design methodology can make it easier to communicate between the team members. Next one, the major goals of the design. The major goals of the design includes uh, first one, the manufacturing cost. Second, the performance. And the third one, the power consumption. So manufacturing cost, in which the cost must be adaptable by the clients. Second one, the performance. The performance includes both overall speed and endlines. That is the performance that given by the embedded systems to the clients, and it should be uh, up to date, and uh, it should be given in a specific deadline. Power consumption. The embedded system must be of less power consumptions. Next, the task needed to perform at every step in a design process. Next, we are going on about the level of abstraction. In that, at every level, these three tasks need to be performed at each level of abstraction. That is, first one, first task is analyze. That is, we must analyze the design at each step to determine how we can meet the specification. Second one is refine. We must then refine the design to add details. Third, verify the design. That is, we must verify the design to ensure that it still meets all system goals such as cost, speed, etc. that are given by the clients. There is two types of design approaches. That is top-down design approach and a bottom-up design approach. Uh, First is top-down design approach, which begin with an abstract description and conclude with a concrete details. That is, it go on in a way like that. First, the requirements will be collected from the clients. Next, it should be specified in a specification manner, and its architectural diagrams will be drawn. Then components collected, and after that the system is final system will be got. In this way, the top-down design approach of an embedded system goes on. In bottom-up approach, it starts with the components to build a system. That is, it happens in the reverse of top-down design approach. That is, first the embedded system, then the components, then the architectural diagram, then to the requirements. In this way, the bottom-up design approach will go on. So this is the level of abstraction. In the diagram given below, we can see the different levels of abstraction. There is 5 levels of abstraction in designing an embedded system. So the arrows that are gone downwards means the top-down design approach, and the dotted arrows that are going up denotes the bottom-up design approach. So the 5 levels of abstraction are: first one, the requirement; second, specification; third, architecture; fourth, components; and fifth, system integration. So first, requirements. In the requirement, the embedded system designer will collect the uh, requirements that are needed by the client in that embedded system. That is like what is the embedded system's purpose, input output function, etc. will be collected in the requirement section. In the specification form, the embedded system designer or the engineer will analyze, then refine into a specific format that are understandable by the engineers only for. It's what the specification step do. In the architectural form, the specified format for the embedded system design will be drawn in an architectural form that to be used overall in the embedded system design process. In the next level of abstraction, that is components, the components that are needed for the embedded system to be made is collected or gathered around in this level of abstraction. Next coming the last level of abstraction, that is system integration. In this section, maybe the while doing the embedded system process, the different that is the embedded system designing will be divided into several parts. So after completing all the parts, it should be integrated together to get the final embedded system. It is done in the system integration part. So I have told it in a top-down design approach, the reverse of this gives the bottom-up design approach. Next is the requirements. That is the first level of abstraction. There are two phases that happens in the requirement. Gathering the informal description from the customer is known as requirements. Second, refine the requirement into a specification that contains enough information to design the system architecture. So in the requirement section, the embedded system designer will gather the information that are needed by the client in the embedded system will be charted as requirements of the clients. And these requirements can be mentioned in functional and non-functional requirements. The functional requirements includes the purpose of the embedded system, input to the embedded system, output to the embedded system, function, etc. The non-functional requirements includes performance, cost, physical size and weight, power consumption. So first one is the performance. In the non-functional requirement, first one is performance. It is the combination of soft performance metrics and hard deadlines by which an operation is completed. That is the overall performance of the machine is included. That is about the speed, the usability of the system, etc. Happen in the performance. Next coming the cost. It includes two types of cost, that is the manufacturing cost and the non-recurring cost. The manufacturing cost includes the cost of components and assembling those components. The non-recurring engineering cost includes the personal and other cost of designing the system. It's happen in the cost section. Then coming the physical size and weight. The physical aspects of the final systems can vary depending upon the application. That is it should be adaptable to the clients, and it should be of a specific size. Consider as an example of mobile phone. It should be of a specific size and of weight. If it's of greater weight, it cannot be handled in the palm or cannot be put in the pocket. So physical size and weight is a major concern in designing an embedded system. Then coming the power consumption, it is a very much important matter in an embedded system design process. If it is a battery controlled embedded system or an plug-in embedded system, power consumption must be of very less. So uh, after collecting the non informal description from informal descriptions from the client, it should be charted in a requirement form uh, by the knowledge of the designer or the engineer. That is, the requirement should consist of 9 sections. That is, it contains name, purpose, inputs, outputs, functions, performance, manufacturing cost, power, physical size, and weight. So these are the 9 points that to be in the sample requirement form. So name that is given to the project or the embedded system. Purpose, it should be described in 1 or 2 lines about what is the embedded system designing for, or suppose what the system supposed to. Input output, in which the input means what type of input we are giving, that is analog, digital, or etc. And output, what type of output that you are getting, if it is an analog, digital, or a video output, etc. In the function, uh, in the function part, it should be more detailed description of what the system does, that is how it works, input output, what does it do, how do the user interface input affects these functions, how do different functions interact. These are all to be mentioned in the functional part. Then coming the performance. In the performance part, we should given how much performance the system will give in an designer form, but it should meet the customers or the client performance that he has mentioned. Then the manufacturing cost, it is also the same as performance, that it should meet the client's noted manufacturing cost, like that if he is the client trying to sell it in a $10, but if the manufacturing cost is about $100, it will not be applicable for the client. So manufacturing should be a major concern. Then coming the uh, next section as power, that is it note the power that to be needed for the embedded system. Then physical size and weight, that it should be mentioned in the length and breadth format, like 2 into 6, and weight as ounce, kg, etc., gram, etc. So this is a sample requirement form. And after the collecting the information from the client, this sample requirement form should be made. Next, we are going to an example for the requirement. The example we have taken here is the GPS moving map requirement, in which we have a moving map obtained from the GPS paints map from the local database. In the below diagram, we can show that the user's current position, user's latitude or longitude position, etc. So the below diagram shows how we can see a GPS moving map in our phone, etc. A sample form is shown here. So the requirement analysis of a moving map by a client is mentioned below, like requirements of a GPS moving map. That first one, the functionality that given by the client as A system is designed for highway driving and similar uses. The system should show major road and other landmarks available. Then user interface. The screen should be of at least 400 into 600 pixel resolution. There should be of 3 button of control. A menu system has to pop up on the screen for the user to make selection. Next, the performance. That map should scroll smoothly. Display should not take more than 1 second, or appear should be able to verify the position and display it within 15 seconds. Then cost. Selling cost should be no more than $100. Then physical size and weight. Device should fit comfortably in the palm. Power consumption. Device should run for at least 8 hours on 4A batteries. So this is the requirements that given by the clients to the engineers. At that time, the engineer will not like this. After that, the engineer will change the requirements that given by the clients to the requirement chart for. That is, we have already mentioned about the sample chart form. That form, the designer or the engineer will be converted the collected information from the client to this chart form. It includes 9 parts that or 9 points that is name, purpose, inputs, outputs, function, performance, manufacturing cost, power, physical size and weight. So while converting from client's requirement form to a requirement chart, the content will be less. That is, it should be written in an engineering format, or engineer understandable format. So in this, name has given as GPS moving map, purpose consumer grade moving map for driving use, inputs power button, two control buttons, output backlit display. It is about the mobile phone, and function uses 5 receiver GPS system, 3 scalable, select the resolution, always display current longitude and longitude. Performance update screen with 0.25 seconds upon movements. Manufacturing cost $30. Power 100 MV. Physical size and weight no more than 2 inch into 6 and of 12 ounce weight. So this is add some requirements of engineering terms that will be useful for the designers. So this is about the that first level of abstraction. So I think you all have understand about the goals of the embedded system, tasks taken in every steps, and the first level of abstraction, that is requirement. So this is all about in this video. Thank you.